So today we're going to be talking about this presentation, which is from cloud to containers, and how the security practices and tools changed over time in order to accommodate the new technologies. This presentation is based on a booklet that I wrote for Mighty Guide and was co-authored with 29 other security experts. And you can see here the pictures of those experts. You might recognize some. And each of the experts actually gave their view about cloud, containers, and how the technology is shifting in that area. I am not affiliated with Tenable in any way, but I was invited to actually give also my expertise and provide some feedback about the book. But before I start, I would like to actually recap the journey in order to get to the cloud and beyond. And the journey starts with data centers and physical servers. At that time, data centers were actually big rooms full of servers. And in those servers, you had a lot of things that you had to do. You had to raise the floor. You had to actually worry about cooling. You needed the physical security for the data center. You also needed the power, 2 sources of power preferably. You needed 2 sources of network in order to keep things running, preferably from different companies. You had also to worry about procurement. Most of the enterprise would have their standards for servers, and you would have to follow those standards. And just to order those machines, get to your data center, configure them, it would take a long time. And more often than not, this became a part of the critical path in a project. In addition to that, you had to deal with the software licenses. Software at that time was a product. And every time that you install, you have to also maintain it by yourself. With time, all those machines that we had in the data centers became more and more powerful. And they were able to do a lot more than just run a single application in those machines. So that's when we got VMs. The first time that I saw a VM running on top of Windows, I really didn't even believe this was happening, because Windows could barely manage memory and disk, right? And suddenly you see a product from, at the time, VMware in a conference that was actually able to manage different versions of Windows running on top of Windows, let alone different versions of OSs running on top of that very same OS. And that was incredible, right? That actually helped us to do a lot of things that we couldn't do at that time. One of the things that it also helped us was with the convenience of recovery. So whenever you have a new release going to a data center, you would need to have a rollback plan. What do you do if things don't work? With a VM, this is incredibly simple. You just take a snapshot, and if it doesn't work, you just roll back to that snapshot. Availability also increased quite drastically. For example, let's say you have a server, a physical server, and then the motherboard goes bad. You can actually take that disk out and actually move to another server, and you have all your VMs up and running in no time. If that server actually doesn't have enough memory or enough disk space, you can actually transfer the VMs to another server on the fly over the network without powering that off. And actually that works if you're using the right type of solution out there. So it really made maintenance of everything that was out there a lot easier than we had before. So the next move, the next logical move, was to move to the cloud. And there were a lot of advantages to move to the cloud. Even if you your enterprise just did a fork and lift to the cloud, they actually got something that was really valuable, which was the higher availability of the physical environment. Because let's face it, companies like IBM, Microsoft, or Amazon, they do a much better job than us, than most of us, maintaining a data center. And that was already valuable. The model that we pay for things also changed. For example, now with the cloud, we had a pay-per-use type of model. So whenever you need a new server, you would press a button. 5 minutes later, the server would come up and running, and you would just start paying for the server now. No more procurement, no more software installation. Software became software as a service, and that was a big change too. So with that, you got faster time to market. So in the enterprise, no more procurement. You don't have to actually go and get the new machines, install, and everything else. And for the startup, you just press a button, and then you have the machine up and running in a well-maintained data center, and you can have your software scaling. And speaking of scaling, with this easiness of just getting as many servers as you want, came elasticity, right? Came this idea of having more servers when you need and fewer servers when you don't need them. For example, consider TurboTax, right? Those guys have a spike when they need servers in the year, right? April 15, for example, a lot of people are filing taxes. Then comes May, June, probably there's, they just, I don't know, turn off all their servers because nobody's actually using that. But they have to pay for that peak of usage, right? And that's something that was very important. So moving to this kind of environment that you have things that are elastic makes a lot of sense, not only for TurboTax, but for e-commerce when they have Black Friday, Christmas, and many other events, depending on what you do, right? This is a big advantage. Now, to have this elasticity, there were also things that needed to change. One of them was how long it takes to actually spin off the virtual servers. When you're talking about virtual machines, and let's say they use Windows, it can take up to 5 minutes to actually get those machines up and running. If you have, for example, a music streaming company, and you are trying to keep up with the demand of a Friday night, 5 minutes to actually come up with all the servers is a long time. And that's where containers actually start to shine. And it came with the idea of microservices. You have smaller type of VMs that actually could do the job for you. And containers are just not like VMs. They're lower overhead type of solutions. Why they have this lower overhead? Because when you have a virtual machine, you actually have isolation at the server level. In other words, you have the entire server that you actually make virtual. With containers, you have this isolation in the application level. What's the difference? Well, you have this base OS. And this base OS is the same for every single application that you want to use. And then the applications are isolated through layers on top of the OS. And that is a really good thing because suddenly you have a smaller footprint in disk, you have a smaller footprint in memory, and you have these layers that makes things far more manageable. For example, you have just enough OS to actually run the application. I had a laptop, for example, that I used for testing virtual machines, and was an old laptop. At most, I could run one virtual machine at a time. When I switched to Docker and containers, I was able, with the same hardware, to run 5 containers. There were 3 Java virtual machines, plus 1 web server, plus 1 database. So it scales a lot better than just the virtual machines that we had in the past. They were far more responsive. The attack surface of containers is smaller than VMs. And the problem with the VMs is that whenever you have a VM up and running, a lot of people treat that as the old technology they were used to, which were the physical servers. So people would actually log in to those machines and then do all the changes there and try to replicate that in other areas. With containers, everything is scriptable. Instead of actually provisioning the server and keep it up and running all the time, what you have is every time that you need, you actually create a new container which goes up and down, and you create images of those containers, and that's what you deploy. So instead of installing patches in every single container in a server farm, what you do is you create this image with the latest version of the OS. And you build this image, and then you put your application on top. So, for example, Node. And then you put your source code. And then, this is how you actually move the container ahead, which makes a lot of sense and changes quite drastically the way you do things as you did before with VMs. The next part of this journey is serverless technology. And with serverless technology, things change also quite drastically. Now, some examples of serverless technology are AWS Lambda, Firebase, and many others, right? And you have this environment where all that you need is your application, and you send to, let's say, Amazon, and they will manage everything else for you. So, in summary, where does that leave us? Well, that leaves us without the servers that we had before. That leaves us without the network that we had before because everything became virtual, and now without the OS. So we gave a lot of the control that we had in the past, and also the challenges I had. So a lot of the challenges that I noticed throughout this journey are the following. We have short-lived assets. So machines now go up and down on demand, different than in the past when you have physical servers or even VMs. You really cannot count the number of machines you have in a data center. If you try to do that, you're going to get a different number every single time because of the demand. We have short-lived cycles. Basically, there's less time for security professionals to actually perform every single activity related to security in this type of environment where you have minimum viable product and you have other methodologies such as Agile being used. Just the loss of control they just talked about. We don't know what's going on with the physical layer anymore. When we delete a file, who knows? We think it's deleted, but there are so many layers of caching and things going on. We just believe that it's doing the right thing. We have the problem of shadow IT. As I mentioned, there's faster time to the market. The type of software that we use actually changed, and now everything is as a service. So it's really easy for people to actually bypass IT entirely and get the software they want in the enterprise without having to ask IT to do the job for them. We have software-driven environments, and there are few people trained in this kind of environments to actually cope up with the technology. And finally, there's increasing dependency on third parties, being for the hardware provisioning or the hardware that we use, as well as the software. So, welcome to the new world, right? What should we do about all those things? How can we solve the problems? How can we actually change the way that we actually do things with security to accommodate this new, the new technologies, the new processes? So let's start with the short-lived cycles, short-lived assets. So as I mentioned, when we were in the physical security times, physical servers, we actually had to provision things and know ahead of time how many servers we need. So let's say you are an enterprise and you want to deploy Active Directory or LDAP, right? Most likely, it's going to be one of the most used applications in an enterprise. You have to go ahead of time, ahead of deployment and decide, okay, how many servers I need, what's the bandwidth it's going to use, and so on. So you go and you are in that blue line. There's zero usage at this point, but you have to buy all the servers, right? And then the usage might go up and down, depending on the time of the day or what people are doing. And if you want to keep up with the usage and you see that it's growing because the enterprise is growing, you have to, again, buy more servers. So you get this blue line, which is kind of like, goes straight because that's your capacity, and then it goes up because you bought more servers, and then goes straight again, right? If that red line, which is the actual usage, actually goes above the blue line, then you are not attending all the requests, right? So you're losing users because they're not being able to get what they need. If it goes below, then what you have is basically a waste of servers, right? It's the case of TurboTax outside the days, after tax is filed. With the elasticity, this problem was at large solved. And you have now this yellow line that you can see over the top of the red line. And if you do things right, you can scale things up and down as needed by looking at your demand, by looking at CPU usage, network, and so on. So that's very convenient. But at the same time, when you do vulnerability management, things don't work the same way. For example, try to do discovery when you have machines going up and down in a matter of seconds, as the case of containers. So how do you do that in this new world? Well, basically, with Docker and technologies such as containers, what you do is you scan the image before it goes to production, right? So you produce this image with the latest version of the OS that you get dynamically. Again, you put the application on top, you can put your source code, and then you do the scan, right? And then you use, okay, this is the image that I'm using right now. And it's immutable, right? It won't change. If you see any changes in while it's running, you can always shut down and then get another container to run and do the very same thing. And that's the best way to actually solve this problem, instead of doing the scan that would take, sometimes weeks to finish using your vulnerability management tool. The next problem that we have are the short-lived cycles. In other words, now software is no longer developed as it used to be way back when, using waterfall models. These days, use agile models, right? And you have very short cycles. They are sometimes 2 weeks long, and there are many sprints. So we came to a model that is more related to minimum viable product. Developers are going to do the list that's needed in order to have a new product, and then see how people use, and then decide the next step, and so on. So the way that we used to do things such as dynamic analysis, static analysis, may not work as well as it used to work in the past. One of the trends today is actually to do a shift left of some of those practices. For example, consider static analysis code. Instead of using a static analysis tool that might take 8 hours to run through the code in order to give you results, what you can do is get a static analysis tool that will actually integrate with your IDE and will tell you all the flaws in the code while the developer is still actually writing the code. It's pretty much like a spell checker for the developers. It won't catch everything. There's some limitations. But the beauty is that if this is deployed and developers are using, sometimes there's not even a need to actually go and file bugs in your, in Jira or whatever tool you use for bug tracking, because that can be fixed right away. Some other tools such as static code analysis and dynamic analysis also start changing. These days we have something called interactive application security testing, or IS tools, which integrates with your batch of tests, and it will run underneath while the testing is being performed. And with this kind of tools, whenever testing is being performed automatically, it will actually do both dynamic and static analysis using reflection of your code. The advantage of this tool is that you don't add a second phase that is just security for your development lifecycle, right? And you get the best of both worlds, getting a report at the end of the phase that you do all your automated testing for your application. Another thing that actually changed was the way that we purchase software, as I mentioned. And there was something called shadow IT that came up. Shadow IT was the fact that people could actually bypass IT and get their own application without asking for IT to, deploy and wait for a long time for that to happen. In the case of shadow IT, for example, you could have somebody in the company going and saying, hey, I need to share files with this customer. Let me go and buy Dropbox. and then start putting all the files in Dropbox, and suddenly the files that are sensitive could be shared, and data breaches could happen that way. So how do you work in such a way that you can avoid this from happening? Well, sometimes the solution is not only, always technical, right? In this case, one good way to actually avoid that is to work with your finance department and say, hey, whenever you see a purchase that is done, that it looks like it's coming from a software as a service type of company, using the categorization of the purchase, let me know, and I will talk to this department and then try to get into a compromise or a way that we can actually manage this the right way. Another solution is to use CASB, the Cloud Access-Based Security Broker, which is just a proxy and will actually give you more control of what people can actually access on the internet and what they should not be accessing. So those are two good ways to actually try to manage your shadow IT issue that you might have. It's also undeniable that we lost control when we moved to the cloud. We don't have our servers. All we are left with is sometimes a SOC report that we believe that reflects the truth and what a company is actually doing. So what do you do in this scenario? Well, basically, when you have a lot of things running in someone else's computer, what you need is to become best friends with legal. And make sure you have SLAs. And that those SLAs are really well written. So you need to actually spell out exactly what kind of security controls you need. And you also need to make sure that you have rights to test whatever is there, and spell out the evidence that the vendor has to provide you, so you actually know and you can see that the security tests are being done as you want. And as I became friends with legal, actually I realized that the entire model and things were actually shifting in a different way. For example, I was doing a lot of legal work and revising SLAs as a head of security instead of actually focusing on the technology and other things that I did in the past. Likewise, all the people who used to work with the appliances and the network and all those physical hardware devices were no longer doing that, and they were actually working with software as code, infrastructure as code, right? They were actually writing code in order to mimic the infrastructure they had in the past. And that really sucks, because basically I was doing something that I was not trained to do, and likewise those guys were doing something that they were not trained to do. So everybody was in desperate need of training, and that's something that I've been seeing in the industry. Try to hire somebody who really knows Kubernetes these days. It's really hard to find, just because it's such a new technology. It's such a radical shift from where you were before that people are just not there yet. The good news is that with this software-driven type of environments, there are also things that came that help us. For example, whenever you have an audit, a lot of auditors would like a diagram of the entire network, or the sensitive areas of your network if you're doing, for example, PCI and other types of audits. Whenever you have something that is defined as code, infrastructure defined as code, you can actually use that as a way to show that there's a faithful description of your infrastructure, but used as code. And you can actually use the same infrastructure you have for production and use for development, staging, and many other areas that you could not do in the past. So that's a big advantage. The days of it working on my machine are gone, because regardless of what kind of platform you use, if it is Windows, if you use Mac, if you use Linux, you can actually use containers, and most of the IDEs these days will actually create the YAML file for your Docker, so you can actually debug using containers in your machine. They're the same containers that are going to be used in the server side. So those are actually really good things that came with the technology shift. But as things shift and then we fix things in one side, we actually created problems in other sites that have not been fully addressed. One of the biggest problems that I see, or areas that became a threat, is actually the CI/CD. Don't get me wrong, I'm a big fan of continuous development and continuous integration, but what I see is that there's a lot of exposure and people are overlooking these areas, okay? Consider for a minute what comes when you're creating orchestration, right? The server or the script has access to the source code. It has access to the OS that is being used and is actually integrating all those things. The config files, depending on how you're actually creating them, they have a lot of passwords, environment variables, and other things that can be very valuable for an attacker, right? There are firewall rules, right? During that time that configuration is going on, somebody could maliciously open a firewall port, a server port that was not supposed to be open. There's the authorization that also takes place there, right? Encryption keys, in summary, is just a great target for any disgruntled employee to actually attack, you know. So it just has the keys to the kingdom. And it has zero redundancy most of the times, right? You have one CI/CD environment. And if that environment breaks, what are you going to do, right? Sometimes the code is not even treated as a first-class citizen. It's not versioned as, source code that a company has or the infrastructure as a code. Integrity checks, who knows? Maybe sometimes some companies are performing them, but a lot of times they are actually download, Docker images for OSs. They are downloading NPM modules, and are they checking that they are actually downloading the right thing and that, that component was not tampered? Most of the times I don't see that happening, right? And as a result, if that part of the system is attacked, you could actually cripple the elasticity and the ability to update your production, which would be really bad. I really wonder if in the future, just like we saw Stuxnet, which was a malware that was very targeted to some specific environment, if there will be malware that is actually targeted to the CI/CD type of environment, and will actually go and start, impact one of the core areas of a company. The source code also become untrusted. These days, developers, whenever they want to do something like a string replacement, they look at each other and go, yeah, there must be a solution for that. Let me go to NPM or Yarn or any of those repositories and just download dynamically the code and in the hopes that this will do, solve their problems. Whenever this kind of system is used, people overlook the fact that they actually employing third-party code into their solution. And I think this is starting to get some visibility. And one of the proofs is that the OWASP Top 10 has, the top 10, most severe type of attacks that are out there, or severe type of loss. And A9 is about third-party code, right? So people are starting to say, yeah, perhaps this can be bad. And it actually can be bad in several different ways. For example, when you download something with NPM, actually there's some script that executes in your machine. And in fact, in the developer machine would be a great thing to do, because then you are actually affecting the source code right there. There's also type squatting. So a lot of times people misspell name of components, and there were plenty of cases with NPM where people were actually putting maliciously other modules out there for people to download. There was just type squatting, and then they were downloaded, and nobody would ever check again. Software composition became a really big area. A lot of people talk about dynamic analysis, static analysis, and pen test. I think it's time to really think about software composition. In other words, look at all the modules from third party that are actually being used, and then see if they are healthy, if they are really what you want to use. And what I mean by that is, what kind of licensing are you actually bundling with your solution? What kind, what version you're using? Are you in the latest version? Is this version free of vulnerabilities? Right? Those things can be actually answered with a good software composition analysis tool, and that's really important. Even the use of the NPM is actually something to be worried about. So for example, if there are developers who are creating components and put on NPM, and at the same time they are using NPM to download components, it's really important to have keys that are different and will give you read-only access when you need and write access when it's strictly needed. In other words, make sure that somebody cannot break into your account and then start infecting the components that you created and you provided to the community, and then the community would be infected with malicious code. The last part that I want to talk about is not related to containers, but it's really related to IoT. And why I think this matters? Because that's pretty much what we're left with in the enterprise. A lot of things actually move to the cloud, and we have these wonderful devices, right, that are proprietary. They have no standard to manage most of the times. We don't know what to do with the end of life with them. So for example, when a manufacturer stops supporting a camera, what do we do with that? Is it going to be still connected with my main network? Should I actually segregate in another network to make sure that it's not going to be a problem? And some people think, hey, that's kind of far-fetched to think that cameras can be a problem. Well, think it again, because there were DDoS attacks in the past that happened because of reflection of UDP packages using cameras. So there are attacks going on right now using IoT and taking advantage of the fact that IoT a lot of times is manufactured by companies that never thought about having a always online type of solution in place. There are some good things going on in this area. One of them is the Iot Cybersecurity Improvement Act, which is really the government trying to say, if I'm going to buy your IoT device, let me tell you what I want you to do. And they ask some very reasonable things. One of them is the device must be able to be patched. We need to be able to manage those devices and actually apply patches whenever needed. We also need to make sure that there's no hard-coded passwords. Very simple, but hey, there were plenty of cases in the past where passwords were hard-coded, right? And lastly, ensure that the vendor devices are free from any known vulnerability at the time they were sold. In other words, if there are common components like OpenSSL and many others that were used in that device, they'd better be up to date. That concludes the talk. I hope you enjoyed and you learned something from this journey from the cloud. Thank you. Questions? Yeah, it's difficult and depends on the compliance requirements you might want to follow. You should work with your auditors and try to understand the requirements. So for example, I know for PCI, some auditors would say, yes, you don't need to do some types of scanners on containers because they're immutable, right? But it will change a lot depending on who is doing the audit. Yeah, so there's something called the Bill of Rights, right? And if you go and look at the FDA and other areas, they actually go and say, hey, here's how I create this medicine, and here's all the components they use in order to create. That's something that, frankly, I've been talking with my company. Hey, that would be really nice to start offering that. But the thing is, components and vulnerabilities are coming out all the time, right? And there's a risk that you actually put in yourself when you actually offer this and you expose to all your customers, right? Under an NDA, it might be something that some companies might want to provide, right? But at the same time, there's a counter argument, which is if I am a multi-tenant type of environment and I have multiple customers using, for example, my software as a service, if I provide you all this information about what appliance, what versions, what components I use, I may be putting everybody else at risk, right? And those guys are your competitors by definition because, you know, they might be using the same service for different purpose. So it's a balance. It's a great thing to have internally. Externally, I haven't seen companies doing this, you know, openly at least.
From a risk assessment.
Yeah, depending on the technology that they use in order to build software, you can actually decompose their software and see. For example, if they're using Java, it's really easy to actually see what's going on, right? There are tools such as Veracode, right, which will also look at the binary and give you insights about the code.
Thank you.